Picture this. It's 4 p.m. on a Friday. You're about to close your laptop and pretend your Jira board doesn't exist for the next 48 hours. Suddenly, a senior security auditor, the kind of person who finds a vulnerability in a Hello World program, pings you. They've looked at your modern microservices architecture. They notice that your frontend is still using implicit grant flow. You know, the one where the access token is just hanging out in the URL fragment like a lost turret in a bad neighborhood. You try to defend it, but Joe, it's been working fine since 2018. It's what the tutorial showed me. Exactly. A tutorial from 2018, back when we also thought microservices will solve all our organization problems instead of just giving us a distributed headache. You've basically built a bank vault, but left the key under a very thin, very visible welcome mat. Today, we are stopping the bleeding. We're moving to OAuth 2.1. We're killing the flows that should be buried years ago. And we're making PKCE, a term most of you can't pronounce, mandatory for everything. My name is Sergio, and I've been building systems for 15 years, and I've spent broadly 10 of those years fixing temporary fixes that became permanent liabilities. I hit the gym 4 times a week to lift weights because it's the only thing in my life that actually stays where I put it, unlike my dependencies. This video is the first deep dive in my new Advanced Backend Security playlist. We aren't doing the getting started fluff here. We're going through the high-stakes architectural shifts that separate seniors from the people who just copy-paste from Stack Overflow. If you are tired of Hello World's tutorials and you want to actually secure enterprise-grade Spring applications without crying into your keyboard, hit subscribe. Let's talk about why your current Auth setup is probably a dumpster fire. Before we dive into the spec, let's address the psychological denial running in the dev community. We love lying to ourselves. It's a survival mechanism. Line number 1, OAuth 2.0 is secure enough. Security isn't a binary state, it's a decay orbit. What was secure in 2012? It's a joke today. OAuth 2.0 had too many optional features. In the dev world, optional means I'm not going to do it because I have a deadline. Line number 2, PKCE is only for mobile apps. This is a classic. I read the first paragraph of the documentation mistake. You think because your React or Angular app is on a secure domain, you don't need proof key for code exchange. You are wrong. If a human can see your source code, your client is public. If it's public, it's vulnerable. Line number 3. My internal services are safe. I don't need MTLS or complex Auth. This is the actual security model. Hard on the outside, soft and gooey on the inside. One compromised container and your entire backend is an open buffet. OAuth 2.1 isn't a revolutionary new protocol. It's a security hardening patch. Think of it as the 15 years collection of all the probably shouldn't have allowed that moments in the web history. The delta. In OAuth 2.0, you had choices. You could use the implicit grant, you could use the resources owner password credentials, you could skip PKCE. In OAuth 2.1, those choices are gone. It consolidates the authorization code flow as the only way to fly, and it mandates the PKCE for everyone, even confidential clients. The goal? Removing ambiguity. Ambiguity is where hackers live. By removing legacy flows and forcing strict URI matching, OAuth 2.1 turns best practices into the only way to get a token. If your Spring Security 6 config isn't enforcing this, you aren't doing a 2026 level security. Let's talk about the bodies we are burning today. The implicit grant was designed for a time when browsers were too weak to handle cross-origin requests. It puts the access token directly in the URL redirect. The irony, we spent thousands of SSL certificates and encrypted databases. Then we put the sensitive token in the browser history, the web server's logs, and the refer headers. It's an architecture malpractice. This is where the user types their username and password directly into your app, and your app sends them to the identity provider. Why it's a technical debt? It defeats the entire purpose of OAuth. The whole point is delegation. The app should never see the credentials. If you're using ROPC, you're just built a monolith with extra network hubs. It's a security anti-pattern wrapped in a microservice slide. The impact in Spring Security 6. Spring Security 6 and the Spring Authorization Server has effectively made these flows a nightmare to implement on purpose. If you try to use them, the framework basically sides at you. PKCE stands for Proof Key for Code Exchange. In the old days, a malicious app could intercept the code sent from the Auth server to the client. Since the code was enough to get a token, the attacker won. The mechanism. The secret, the client generates a random string, the code verifier. The challenge, it hashes that string to create a code challenge. The first leg, the client sends the challenge to the Auth server. The exchange, when the client finally swaps the code for a token, it must send the original code verifier. The server hashes it and checks if it matches the original challenge. If the attacker steals the code, they can't use it because they don't have the code verifier. It's simple, it's elegant, and you have no excuse not to use it. Let's look at how we used to do things versus the modern, battle-hardened Spring Security 6 approach. This is what you see in those tutorials that haven't been updated since the last solar eclipse. It allows everything because it's easier for development. Notice the strictness. We use S256 for PKCE, remove the password grant, and ensure the client settings enforce security. Why do we still see ROPC and Implicit Grant in the wild? The cargo culting. You copied the config from a project that was built by a guy who left the company 3 years ago. You don't know why it works, so you don't touch it. The MVP trap. We will fix the security in phase 2. Phase 2 is a myth. It doesn't exist. It's the developer version of the check is in the mail. Ego. Admitting that your architecture is flawed requires humility. It's easier to say it's an internal tool than admit that you are one XSS vulnerability away from a data breach. I can already hear the comment section warming up. Well, Sergio, if I use a strictly validated state parameter and then nonce, the implicit grants is technically manageable. Listen, just because you can perform strategy surgery with a knife doesn't mean you should. Why would you spend time trying to patch a fundamentally broken flow when the spec creators, people much smarter than both of us, are literally screaming at you to stop using it? But PKCE adds an extra step to the implementation. It's 2026. Spring Security handles the heavy lifting for you. If you complain about an extra 10 lines of configuration, you're not an advanced backend engineer. You are a typist who's afraid of the documentation. If you want to move to OAuth 2.1 today, audit your clients. Find any registered client where required proof key is false. Change it to true. Kill the password grant. If your frontend is sending usernames and passwords, stop. Implement a real login page on your authorization server. Update Spring Boot. If you're still on Spring Boot 2.x, you're just behind. Move to Spring 3 and Spring Security 6. Rotate secrets. While you're at it, move those secrets out of the application YAML and into AWS Secret Manager or Vault, but that's a topic for the third video of this playlist. OAuth 2.1 isn't here to make your life harder, it's here to make your application harder to break. Stop following tutorials written by people who don't have to support the code they write. In the next video, we're going to talk about granular authorization, moving beyond the hash role admin and into the world of ABAC and RBAC. That actually scales. Now go delete those deprecated flows and stop treating your security like an afterthought. See you in the next video. Bye.